Let's take a look at another increasing and decreasing example. We want to figure out where this function f of x equals negative 2x cubed plus 4 increases and decreases. This is example 3. So remember, you're going to find the critical values first. You're going to take the derivative of this function using simple power rule. Negative 6x squared, derivative of 4 is 0. So you have a simple derivative. Now we know this exists everywhere, so for critical values, we just need to set it equal to 0 and solve. This is also obvious. This is one single term, so we know x is going to be equal to 0. So we only have one critical value. So that means we're going to have two intervals. Now we were not given a interval here like we did with the trig function, so we're now going to start at negative infinity and end at infinity. So it's going to be from negative infinity to 0 and 0 to infinity for our step 2, determine our intervals. Those will be our two intervals. All right, next we're going to draw our chart out. We're going to have two rows, one interval negative infinity to 0 and the other from 0 to infinity. Now, easiest test value here would be negative 1 from our first interval, and then from 0 to infinity we're going to plug in 1. Remember, plug that into the derivative, write your derivative formula up here. When we plug in negative 1 into our derivative, it's going to be negative 6 times positive 1, which is negative 6. That tells us we get a negative back, so we know it's going to be decreasing on this interval from negative infinity to 0. However, when we plug in 1 into the derivative for our second interval, we get negative 6 times 1, which is also negative 6. So check this out. It went from decreasing to decreasing. What does that mean? Well, it just means it's decreasing on those two intervals. Now, be careful, okay? It will not be decreasing at 0. That is a critical value, okay? A function can't decrease or increase at a critical value. So it's going to go from decreasing to decreasing at 0. So you might be thinking, well, what's happening at 0? Well, remember, for a critical value, either it doesn't exist or it's a horizontal tangent. And I can tell you for this one, it will be a horizontal tangent. Okay, it's where the derivative equals 0, and you'll have a horizontal tangent. So we'll go from decreasing to flat to decreasing. Let's read our verbal explanation here. It's decreasing on negative infinity to 0 and 0 to infinity because the derivative is negative for all those x values in those intervals. Note, since f prime of 0 equals 0, it is not decreasing there. So all that to say, let's go ahead and take a look at the graph, and you're going to see what we're talking about here. We're going to look at the tangent line. We're going to trace it out. This is, again, negative 2x cubed plus 4. And we can see that it's decreasing there, right? And then what happens? It ends up being a horizontal tangent right there, but then it starts to decrease again. Okay, so again, right at 0, there we go. Right at 0, it's not decreasing, it's flat, but then it goes to decreasing again. So what does this mean? When you're doing these charts, it's not always going to alternate from increasing to decreasing, and that's going to lead us to our next lesson, which is where relative min and max occur, which is only when it changes direction. I do want to make you aware of one more thing. I do have an app that you can load up and type in your function right here and look at the intervals where it increases and decreases. For this particular one, it goes from decreasing to increasing. Okay, so that's it for this particular example of a function that goes from decreasing to decreasing, and sometimes it can go from increasing to increasing. If you have any other questions about this example, let me know.